So, welcome. Hopefully we won't have too many contradictions, but that's not a bad thing in knowledge management from your workshop yesterday, because I'm going to challenge some of the things that we're reading about knowledge management and AI, because most of it is focused on how AI is the miracle thing that's going to solve all of these problems that knowledge management has faced for years. Like it's going to do all this auto-classification and summarization and all this, and maybe it will, but not without our help. And so I'm going to concentrate today on what you can do as knowledge management professionals and what your role should and could be when you think about the world of AI. Because I'm guessing, and maybe by a show of hands, how many of you were actually invited into a machine learning session to help figure out what the data was going to be in your company? Anybody? Couple? Okay, well, that's good. All of you should be if you're doing machine learning, AI, and or IoT. If you're in the industrial space, you should be being brought in to think about what that means, and I'll make that case earlier in a little bit. So tweet and story away. I have the feeling we may have an issue with the presentation because I think this is right. Sorry. So Instagram and Twitter. I made some last-minute changes last night, and I wanted to make sure they were on there. So Instagram and Twitter, feel free to do that throughout the presentation. And I'm here all week through Thursday evening, so feel free to talk to me afterwards. Just by a brief introduction, I run Serious Insights, which is a boutique analyst firm in Sammamish, Washington. I'm also part of the HiveMind Network, which is kind of my representation in Britain and Europe, and I have to say that now because they're not all the same. I come from a wide background of AI and industrial experience, from doing the surface mount assembly reasoning tool at Hughes at Western Digital, and then doing a lot of knowledge management stuff, including the Knowledge Highway project at Hughes Aircraft. I want you, as I said, to think about how we get involved in the technical side and in the philosophy side of AI and IoT. And part of that is thinking about what we do well and what machines do well. I know this is an eye chart. The slides are up, so feel free to download them. There's a PDF up there of everything. But this is really thinking about what do humans do well, and there's other pieces of this. Deloitte's done kind of a brain map thing that looks like this. I disagree with some of the things they said AI does well. That here, but just to think about, there's still a lot of things that we do as humans that machines do not do well, and I personally doubt that they're ever going to do well. I don't think we're going to get to the point that we're going to have conscious machines. I think our biggest issue from the threat standpoint of people who are worried about AI, and some of you may be in the room today or in this track because you're worried about what AI is going to do. AI is going to carry out human intent, and the biggest threat is the human intent, not the AI. I think that's something that you need to really concentrate on. AI helps from the standpoint of being an assistant and being a proxy, and I think that's as far as we're going to get. I'm not sure it's ever going to be a full replacement for all humans. There are certain jobs that we have probably, unfortunately, given to humans that are boring, mundane, stressful, and yes, in some cases they may be well-paying jobs, but they're jobs that if we really think about it from a moral standpoint, we may not want humans to do those jobs. And there are better jobs for them to do. In college, I'm actually a trained poet. I would love for the world to think that was a good thing. I've made $12 so far writing poetry. Maybe AI will allow me to make more than $12 doing that, and we'll reappreciate literature again. In terms of the kinds of solution spaces that we think about with AI in particular, proactive scheduling, preventative maintenance, dynamics scheduling, spam filtering, fraud detection, et cetera. Those are all areas that I believe that AI is actually going to provide a very deep and resonant solution space, and a lot of other kind of tool sets that you're going to see. You're going to have vendors, you may have them in the solutions showcase today, talking to you about some of these, both solutions and the technologies behind them. because increasingly we're going to get toolkits that we're going to be able to fashion into our own solutions, and I think that's going to be better than what most of the solutions are offering, because all of these, very much as you know from KM already, are going to be very unique to your business. They're going to be contextual. Even if you're in the same business as someone else, your business is really different, and you have to think through what that looks like. So everything from decision support to how do you think about data in context, right? These are things that we've been talking about in the KM world for years, and yes, AI can help with those, but we have to think about how we participate in that. So just to give you a myth of intelligence, how many of you have an Alexa at home now? Does anybody do more than 25 things with it? No. Because why? You can't remember what you're supposed to do with it, right? And this is one of the problems that we're seeing, and this is a great example that's very much in the consumer space that we're seeing with AI, is that if I want to go into a Doctor Who quiz, I have to tell Alexa that I want to do a quiz on Doctor Who, ask Doctor Who a question, but I have to remember that that's a skill I've enabled, so I have to now remember all of these skills that I've enabled. And then I have to remember the vocabulary that the skill builder has embedded into the system. So when you look at the architecture of Alexa, there is this very, very fine natural language processing system that will parse, most of the time, parse what you're saying, unless your daughter's name is Alyssa, which mine is. And so very often I'm yelling, Alyssa, it's time for dinner, and she's going, I don't know what to do about that. And that's a minor flaw. I think the bigger flaw is just the architecture side, right? And so again, this myth that because we have one piece of a problem of cognitive computing solved where we think we can actually have this natural language dialogue, the back end stuff is all knowledge-based. And we haven't figured it out, and Amazon knows this. Amazon knows that the skill architecture is a little clunky, right? And so a lot of the things that you're actually going to see when you get pressed to look into the underbelly of the AI, and we'll talk a little bit about IoT as well, because I think they're closely related. When you get to those, you're going to find that they're clunky. So let me give you a worked example of both of these together. I did some work with a industrial company recently, and they are in the testing space, and one of the things that they wanted to do was narrow the window for maintenance, right? So you have these big industrial machines, and you have these factors of production, quality, labor, and inventory, and if you take a machine down for too long or at the wrong time, it interrupts the production line, and you don't get as much stuff out the back, or you interrupt it at a time and introduce a new variable, and you bring down the quality. You also have to think about who can repair the machine and when are they available. There's all this stuff that has to happen. And of course, the answer to all of that is that we're going to use AI to figure out that complex coordination of all of these resources, right? And typically today, most companies, and they still do this, have a guy with a clipboard and sometimes maybe a manual tester walk out to a machine and see how it's doing, right? They have these things called walking paths, and they literally, and this is knowledge transfer from one generation to the next, they go, we're going to walk around to the machine. Okay, let's see how we're doing over here. We take some notes and get some feedback. We go, oh, there's feedback in that one. And then we take those paper notes and we go upload them someplace. And maybe, if you're really sophisticated, you use your iPad or a mobile device and you upload it in real time. And maybe you do something where you analyze that information and you say, well, there's something that we got to go fix on that machine. Most machines today are still on scheduled maintenance, right? So you get a manual, and the manual says every 6 months do this thing. And every 6 months you do that thing. And again, that's a little easier to schedule. You can go, okay, we're going to go on Saturday morning, it's downtime, we're going to fix that. But what we're finding is that machines live in the real world. We've kind of always known that. And the AI people and the IoT people are going, let's just outfit them all with sensors, right? Let's put all these sensors on this machine: sound, vibration, stress, pressure, level sensors. Is it still level on the ground? Smoke and gas sensors in the environment, right? Because you can have all this stuff that happens, and what they're finding is that if I take a machine, I go, it should be serviced every 6 months, and I stick it in another environment with higher humidity or different heat signatures, maybe I have to do it every 3 months. Right? And you think about what your car does. If for most of us now have automobiles that are saying your oil needs to be changed, it's like 34%. It's not every 3,000 miles or whatever your maintenance program is supposed to be. Your car now tells you that you have a percentage less. And that's based on your driving patterns. If you drive hard and fast versus slower and less frequently, it's going to change that percentage. And so what we end up with is a lot of sensors with a lot of information, and this is a place where you have to have some knowledge management input, because what are those sensors doing? What makes sense? Have you analyzed the situation? Because that guy with the clipboard doesn't know about these sensors, right? These are new. These are being sold by new vendors coming into the space saying, I think we have this idea, right? Sometimes they're not new vendors. They're places like General Electric. But even General Electric is finding that it's a hard sell, because you've got these people who know these machines. They can literally walk up. Anybody watching the Haunting of Hill House? Everybody's going, no, I'm not watching that. One of the characters can touch stuff and feel things, and that's what industrial test maintenance guys can do. They can just walk up to a machine and go, it's vibrating too much. And they can sense that because they've been doing it for 20 years. And now we can put these sensors on that. So there's also this whole transition issue of are we going to have displaced workers, because the guy who senses it can now be replaced by a sensor, right? But that whole knowledge piece of what are all these things that we can do, including, as I was alluding to earlier with the walking around, I can now put cameras all around it. I can put water sensors. I can just see the machine. I don't have to go walk up to it. But then what do I do with all of that stuff? Right? And so there's this kind of emergent area of machine learning, trying to make sense of all of these things. And the engineers that I've talked to, one of their biggest issues is the data is not clean. I mean, they've literally looked at me and said, the sensor data doesn't make any, doesn't help me, because we haven't figured out how to format the data. We don't know what to throw away and what to keep, because it's sending out so much information. And that's, again, a cognitive process. We have to think about that. The AI is not going to do that. The AI may, at some point, take all of this sensor input and say, this machine's likely to fail in the next 24 hours because of a motor that's overheating, because it probably, and the reason motors overheat is because it probably has a low oil level, right? And so that's what they want to get to. Then they add that together with the production information and say, how do we get down to writing a work order that's going to do what? Bring the maintenance window into as small a portion as we can. And then how do we collaborate on all of that? How do we think about the human side of that? But there's a lot of information, and a lot of it is not something that it's I would say precognitive, right? It's all of this information that we have to bring together that makes sense of. And there's an example. iChart, again, slides are on there. Don't expect you to read that. But everything from corporate data to maintenance data, environmental data, OEM machine data, because all these machines come with training materials. They come with maintenance schedules, maintenance manuals, all this stuff. And then there's a new level, of course, with outsourcing, where some vendors of machines are coming in and saying, we'll just do this all for you. And they plug their machine into your production line, and that's the one machine that gets maintained by somebody else where that data is going out. And another knowledge management problem is what does it mean that our data is now going out over a public cloud or even a private cloud? What does it mean that it's leaving our building because we think that's proprietary and we think it's information that needs to be protected? And we now have a vendor that we've outsourced that to, and they're sending their machine data out to the world, right? So that's big in food processing, where they're now putting those in. But it's not the only machine. So you now have a machine that's sending stuff out and maybe doing predictive maintenance, and you've got all your other stuff that you're still doing with a clipboard. And so there's this dissonance that's also happening. And again, that's a planning process. That's not something that AI is going to solve. And so when we think about this idea, because the way to get to the smaller window is predictive analytics, right? How do we get to the point that we can predict when the most likely time there's going to be a machine failure, and then on top of that, either advise and or predict when we're going to actually get to the point that it's the best time to make the repair, right? So we want to get to the repair before the piece fails, before the piece of the machine fails, and when it's least impactful on the organization. And so these are all kinds of things that have to happen from the knowledge standpoint, from figuring out the best use cases, to understanding the data, to deploying the sensors, and what sensors do we use, and what's that network look like? How does that integrate with all the other data that we have around the organization? How do we format it? How do we make it clean? How do we get it to the point that it's useful? And then how do we get to the sources of data so we can have the predictive models? And the predictive models themselves have feedback loops that require human feedback, right? Because you're going to have this data come in, you're going to have the machine make some predictions, and sometimes they're going to be wrong. Many times early on, they're going to be wrong. And you have to go, why are they wrong? And this is one of the big issues with, and we'll talk about it in a second, the black box side of AI. Because they're sitting in an enclosed space where there's no chance of understanding what it decided to do and why. And there are some solutions to that I'll talk about in a moment. And then collaborate, and so the traditional stuff that we do with lessons learned and how do we connect with each other and have a conversation about the why things aren't working, and then iterating and deploying, and then finally getting to some sense of the how do we narrow that window, how do we get to a analytics that's on top of, so this is layered analytics, right? So if I can figure out when the machine's going to fail, I can then figure out when I can put this other data in. This is complex stuff. Right? This is not something that you're going to go hire somebody out of Stanford or MIT or Carnegie Mellon and just have them walk into your facility and go, we have this really big factory and we got all this data and we're going to have even more data because we're going to put sensors all over stuff and we don't even know how those work. And since you have a PhD in analytics and computer science, we want you to fix that. It's not going to happen. I mean, how many new graduates out of MIT, Carnegie Mellon, or Stanford that you put in any job that you expect them to come in and go, yeah, I know how to, that's easy, I can do that, right? It's experience, it's knowledge transfer, so there's a scaling upside, and I'll talk a bit in a minute about your role, perhaps, in how do you hire people to make sure that they can do this kind of work. So again, it's how do I, that all of that stuff is trying to answer that one question of how do I fix a machine in the smallest amount of time that's going to be least impactful to my labor, my quality, and my organization. And then it can get even more complicated. So I've spent a lot of time doing artificial intelligence, Internet of Things, and virtual and augmented reality. I don't know if any of you were at my talk. I did the closing keynote a couple years ago on virtual reality and knowledge management. But think about on top of all of that, if you're actually doing the maintenance, the manuals say, take part A and insert it on top of part B or something like that. It doesn't have the spatial coordinates. So there's all this other stuff that you have to add into a system if you want augmented reality to work. You have to understand the spatial relationships, and you actually have to have, which you often don't get with machinery that you purchased, all the schematics for them. So that in spatial orientation, so it's not just the wiring diagrams to say this wire does this thing or connects to this point, but you have to actually understand how things get put together, and then you have to create this work environment. And people don't think about that. That is one of the biggest difficulties with augmented reality is how do I get the guy who's giving me advice and the manual and the checklist in the right places so that when I'm doing this work, I can actually concentrate on the work, and those are my peripheral vision, and what happens when I turn, and how do I keep the orientation to the work that I'm doing. And so there's all kinds of new ways of thinking about the knowledge and how it gets chunked up. And again, probably not something that someone who's never worked in a factory, never repaired anything is going to do for you very well. Another example of this is a company I'm working with now. It's a startup called Weave.me, and they're a decision support company. They're doing a lot of gathering of information on the internet to help people, for instance, financial analysts, make better decisions by providing them analysis of financial market information, reports, blogs, webinars, all kinds of things, and trying to get to the point very similar to the previous one, which is instead of worrying about the how narrow can my window be for maintenance, it's what's the right information that I need to make the decision I'm trying to make right now. The difficulty, how do I model the decision I'm trying to make right now? And so this front end part of theirs, the domain modeling, is a piece of that. So what is the financial market? How do we describe that to an AI? So once we describe it, we can send it off and it can figure out stuff, but we have to figure out how to describe it first. And that is not a machine learning problem. Yeah, it is. It's a problem for machine learning, right? Because the machine learning doesn't know how to take that information from the web and just kind of guess. This might be financial stuff. You have to actually teach it what financial information is. And then the knowledge map has to be validated. And those, again, are all inputs. The visualization stuff and the creating semantic networks, that all kind of happens like magic, and that does happen. But if it doesn't have validation, if it doesn't have a good model on the front end, then you end up with information that is not overly useful. So when we talk about the knowledge black box, this is what most AI does, right? You have a difficulty having a conversation with your artificial intelligence about why it reasoned the way it did. Now, this is a big contrast to the old AI, right? So when I did the surface mount assembly reasoning tool at Western Digital, that was a rule-based system, although it did have a black box in it. So it was a rule-based system, and I could very easily go in and say, why did you decide to place this component on that machine using this head, right? So it was trying to place components on a printed circuit board. But there was a piece of that was a traveling salesman problem, which was what's the optimal path for picking the way that the heads interact with the printed circuit board. And we used the genetic algorithm to evolve that problem. We could not ask the genetic algorithm why it made the choices it did. We could ask the front end of the system why the rules generated the results they did, but that black box was still there, and that's very common in AI, that there's some kind of algorithm being used that has inputs and outputs. And you can look at both of those, but you have no idea what happened in the middle. And for knowledge management people, that should make you very uncomfortable. And it also makes you very uncomfortable if you look at what has happened recently with Twitter and Facebook, et cetera, in the context of our elections. They have had to bring in people to start looking at what their algorithms are doing and saying, are they catching everybody that's doing things that are anti-election oriented? Right? And that is not something that the AI is doing. They are bringing in people to backfill that thinking process. Right? And so we have to be careful. There are things in there, if you read about these, I'm not going to go into them in detail, local interpretable model agnostic explanations and interpretability of top inputs from the AI models or graphs and latent explanations of neural network scoring. Those are all things that put noise into the system and kind of try to track stuff about what's happening inside the algorithm. But you have to build these big things on top of the supposedly efficient, because when you hire a programmer, you're hiring them to be efficient. What's the most efficient way to get to this decision? So that we use the least CPU, that's their thinking. And now you're saying, I want you to insert all this stuff that tracks all of the things and makes it inefficient. Right? And so this is emergent technology that we're just starting to see, and there's probably going to be more of those things, and I'll leave that to you to go study on what those keys that unlock the AI are. And then we have some other information, other issues with data. So one of the big things, and I don't know if you've been watching any of the AI news around bias and prejudice inside, because as I mentioned earlier, intent, the human intent of the system is key. And a lot of that is not the design of the algorithm, but the design of the data. the data that you use to train a machine learning algorithm will decide how biased or unbiased it is. And we tend to have biases even when we don't think we do. And our data certainly does, and our systems certainly do. And so we're finding, for instance, that in the case of Compass, which is a sentencing tool that is actually in use today by judges saying, we think these people are more likely to commit a crime in the future than other people. And because of the data, they tend to pick people of color more often than white people, regardless of economic background or any other situation, because the data about recidivism is actually biased. And they're now having a big debate about that. One of my favorites is the Microsoft Tray, which is a Twitter chatbot. 24 hours is how long it took for the data to make it into a racist, right? So the data actually reinforced, and it said, we're going to go have this conversation, and we're going to learn what people talk about. And what it learned, because machines can learn much faster than we do, which it should be a lesson for lots of things, right? That the data in one of those bubbles of information was so biased that the chatbot became racist in 24 hours and was shut down. I think there's a lot of learning that can be done from that. Facial recognition in search, right? So we have facial recognition at IBM and Microsoft, et cetera, 99% accurate at identifying white men. Right? So again, there's a bias in the data. Google search, 11% of images were women, 27, searching for CEOs, 27% of CEOs are actually women. So the data that was used to train it is not good enough. Right? And by the way, if you find typos, which I'm finding as I do this, feel free to point them out to me, and I'll upload a new version of this tonight so that you have a typo-free version. And then news search, and again, that whole idea of the how do we confirm and corroborate the information, and when we have these bubbles of information that are biased by nature, and we put a chatbot into that, and we use that data to train it, it's going to reflect the bubble. And that is true of information that you're using if you're talking about, repair information, or if you think about your customer service or your view of your customers. That information that you have and the stuff that you do, if your company is biased toward, let's keep a lot of information about the best customers, because that's one of the things that we do. We're going to learn about our best customers. And you don't keep as much information about your not best customers, then a lot of the decisions you make coming out of machine learning are going to be based on the here's how we reinforce the best customer thing, but not how we convert the people who are not our customers, because we haven't paid attention to that. So again, the intent, the question that we ask. I'm doing some work with a group called Faith in AI, because the powers that be in the technology community have decided that we need a new ethics for ensuring that we are not destroyed by artificial intelligence, in particular autonomous vehicles that have weapons on them. So they've written a letter to the UN and said we should stop this. Our group is actually saying, well, we've got 4,000 years of tradition about how not to be bad to each other. Maybe we should use that first. But what we're finding in our research is that, it's about the human intention. And one of the great examples of that is if I have a machine learning algorithm that is put into a weapons system, and I say, I want you to take out the elevators, and it's standing here in front of me, and I say, I want you to take out the elevator B in the most efficient route possible. Guess what happens to all the people in this row? They all die, because the robot has not been trained to avoid human issues, right, and throw out Asimov's rules of robotics, right, because this thing has an intent, and it's the most efficient. I've given it instructions, be the most efficient you can, and walking around people is not efficient. It's going to go through you, right, and that's a bigger problem than the machine learning side of it, right, or the AI deciding to do something. Right now, there's really not a lot of AI that decides to do things on its own. And what we're finding when we look at autonomous vehicles, for instance, is that system is so complex that when it is asked to make decisions on its own, it has some difficulties doing that. And it's a lot safer in the picture I showed you earlier of the industrial machine where you don't quite get that maintenance problem right. But when you get to the point of having an autonomous vehicle in the wild, as I call it, when you have AI in the wild, that's a different thing, right? And we have to think about how we consider that data. Now, one of the things that I've recognized in knowledge management for years is that the better we get at instrumentation, the farther and farther we can look out into space, the more we realize that the thing we thought we knew gets changed or thrown out because the new instrumentation gives us a new view, right? And so there was not a lot of understanding a few years ago about how, were there big structures early in the universe? And this is an example of 1 billion light years away, 1 billion light years in diameter, sorry, of this big structure that people are having a problem trying to figure out how did the early universe actually create this thing, right? How did this happen? And, is it dark matter? And we don't know, right? Because our instruments have now, we no longer just look at the moon or look at Jupiter, which is what Galileo could do. Galileo couldn't see this, right? He could see Jupiter and go, oh, maybe the Earth kind of goes around the sun like the Greeks said it, But now we have new structures. And the same thing happens on the other side, right? So if you were in chemistry class, you saw this thing over here, you build those out of the little sticks. We can now see that it's actually accurate. There's a picture of an atom, but they don't understand all the forces in play at holding an atom together, right? We can now see it, we know we're accurate, but we don't understand all the forces in play. And there's this, kind of huge ongoing thing about quantum gravity and quantum physics and relativity and what does all that mean. And we're now doing that with AI, IoT, et cetera, because as we think about the knowledge management side of the world, right? If I was, my friend Steve Denning was up here, he'd go tell stories, right? If you're it's very difficult to tell stories in nanoseconds, right? Or picoseconds, or pick a second, right? That story's done and over, right? There's all this information coming in from these sensors that's giving you, I never use the term real time, that's why it's in quotes, because everything is historical. There's nothing that we can see in real time, even the stuff that I just said is already in the past, right? And then we have repositories and over dinner maybe, or whatever, you guys can help me fill this out because this is kind of new conceptually about what are the relationships, but gives you a sense of I've got things that I've collected for years and I'm holding on to them, I can mine them, I've got lessons learned that are I've got to do something with them because they have to be applied in a relatively short period of time where the world changes and they don't matter anymore. I've got after action reviews, which is something just happened and what does that mean and what do we do better? And hours, minutes, seconds, and all the different kinds of seconds, right? And so the more we get to this instrumentation on that side of we're now peering into information and content in ways that is completely different than the things that we traditionally keep as knowledge managers in repositories. We don't know what to do with that, right? How do we deal with that kind of information? And I think that's the struggle that this track is really trying to guide is how do we get to the point that we're understanding our role as not knowledge managers. As I said, I did a book on knowledge management by design. I think the key thing here is the very top thing I ask people to do in the methodology in that book is to balance things. That's the first thing you have to do. And so there's all kinds of things about balancing on strategy and balancing for meetings between the organizers and the attendees. In this case, I think we're talking about the depth of history and infrastructure and balancing against the moment, right? So we have these huge areas that we think about as knowledge managers. How do we keep the culture? How do we think about the strategy of the organization? How do we enforce that? Down to now we have knowledge about machines that are giving us stuff in near real time in very, very small increments, little bits of data that we have to then correlate and make sense of. And that's a very different problem. So the first piece of advice is balance where you're paying attention. And I think that's an area that you may have to do some shifting. If you're paying attention to traditional knowledge management things and you're an organization that's doing machine learning and doing IoT, you now start to shift and think about how do I balance those two sides of that spectrum. And ask yourself, what's your role in the strategy, right? And I'm not going to give you the answer. Every organization is going to have a different one, but you need to ask that question. You also need a team on data design, test for biases when it's KM and ML, determine what questions to ask, and look for shifts in the underlying assumptions. And this is a big issue, right? So everything is contextual. We say that as knowledge managers all the time, including all the AI stuff. So the machine learning guys come in and they go, oh, we got all this data, and here it goes. And if there's a shift in business strategy, maybe that data isn't accurate anymore. Maybe you've decided you have a different intent, and the intent of that system that's now mining all of this information and giving you decisions is not aligned with organizational strategy anymore. And the machine learning guys aren't going to necessarily know that. So we have to think about what's the change management side of AI and ML. And knowledge management for IoT, environment design, thinking about the bigger picture, and the systems design integration of existing data. Where is the stuff? What do we know about our organization in terms of data? And leverage to find value should be that. Leveraging insight to find value. And then also, as I said, and again, these are in the slides, thinking about how you help hire people. How do you define the roles so that you're not just hiring computer science people that are good at taking data, maybe cleaning it up a little bit, but that they actually understand the business, and then how do you build teams around them that are helping transfer the knowledge and the intent of the organization to these people who are relatively new to business, right? They're not going to be traditional business people that probably evolve through the organization. They're probably going to be new hires at probably twice to 4 times the amount of money you're making. Because they have these computer science, ML, AI degrees, which also probably brings an air of arrogance with it. And so you have to think about how do we manage these people who think they know a lot of stuff and bring them along to realize that they don't know as much as they think they do about the business that they're entering. And then also the challenge on the ethics and morality side of becoming the conscience of your business, right? So that's something that's probably in nobody's job description, but it's one you may want to think about is as your organization, and I keep talking about intent, that having the purview of what does the organization know, and kind of prodding it back and forth, going, maybe that's not the right choice. Maybe we should think more about this before we do it. And that's a role I think knowledge managers can play. And I'll take some questions if you have them. I think we ended with a few minutes left. Thank you. And feel free to reach out to me on any of these channels.
Are there any questions out there? Surely something has sparked in somebody's minds at some point. Yes?
I'll make a comment that
yes.
you can respond to.
Sure.
Your slide showing a timeline from decades down to picoseconds, whatever it was. Have you ever heard of the concept, the specious present? The idea that there is a sliding time window that humans have in their attention, 5-7 seconds, that's considered the present, and maybe we would have a similar concept that's applicable to artificial intelligence.
It may be, but I think AI is probably going to have, it's probably a longer conversation. I think AI is going to have the ability to shift paying attention.
That should be task-oriented.
Yeah, and it can do it because we may have this physical constraint for how we pay attention, just based on biochemistry in our brains, and we can probably engineer AI to do something, to pay attention in a different way. But that's an interesting challenge, right? And that's where it's going to be doing something that we don't know how it does it, and we can't relate to it directly, because it's going to be able to pay attention to stuff that we would get bored with, right? And then we still have to figure out how to manage it.
See, wasn't that a cool question? And you learned something as well.
Yeah.
The other thing that comes to mind is that humans have this visual processing problem that we actually only see 3% of what's actually around us, and we make up the rest of it. So not only is it a time-bound question, but it's also a very narrow, at least from a visual point of view, very narrow focus. And of course, AI can look at 10,000 things and have inputs and pay attention.
Well, and that's actually not 100% accurate in terms of what we can see. We actually see it. It's what our brain decides is important, right?
Well, then we can get into philosophy. philosophical.
Right, but that's the
What it's
thing.
seeing.
AI is going to see it, we see it, and it may decide different things are important than we see. Right? And so that's an interesting, yes.
I like how you characterize so many different things that are called roughly AI.
Yeah.
It's so confusing sometimes, people bandy that word about. But from all the things that you were talking about, what have you seen as being the most actionable for folks wanting to leverage AI and knowledge management today? Because a lot of things are coming, some are here.
Yeah. Well, I think the traditional stuff that we thought it could do, I think it's getting better at doing that, and you'll probably see some of that in the showcase, right, of things like auto-summarization of content. So if you think about traditional AI stuff, nobody tags anything. I mean, I've been on, I worked at Microsoft, right? Nobody at Microsoft.
You newbies, no one ever tags or structures anything
Yeah.
other than the librarian type people.
Yeah. And so, yeah, I worked at Microsoft. The SharePoint deployment was, you got an email saying there's a new version of SharePoint. That was the deployment plan, right? And then go figure out how to use that. And we were the worst at doing it, and nobody tagged anything, right? And nobody used the tags inside of Word. I mean, I know they're all there, but I think having computers do that, and I think they do that pretty well. But again, it's the training set is what matters, right?
What's your recommendation if you're working at a company where the people who are much higher up above you think AI is the end-all be-all and think it's just this magic fix?
It's tough being the conscience of the organization, right? So that's always been true, right? The executives know what they're doing. The people who they've hired, again, at probably up to 4 or 5 or 6 times the salary of a lot of knowledge managers. They're going to trust those people because they go, oh, they've got an AI degree from Carnegie Mellon, and they know how to do this stuff, right? And I think, it's tough being your own, your conscious that you listen to or don't listen to sometimes yourself. It's tough doing that work inside of an enterprise, so.
So I guess the only other thing I would add to that is that you do not want to be in the position of being a nag in your organization. A lot of KM people end up in that, oh, you shouldn't do that, or we should structure that, or what about the other? So the flip of it is this a wave that you can ride? And how would you do that? So how do you enable and support it and guide it and shape it in the right direction rather than say, whatever.
Yeah. However, if your organization is completely doing things that are either unethical or going to drive it out of business, probably not horrible to be a nag, right? Go ask the people that work at Sears. If could have used some nagging, they might still be in business. Right?
And there we get into the question of balance, and I think
Yes.
The phrase I use is, there's polarity management, that you actually have to manage 2 things at the same time that are somewhat contradictory, and it's really, there is no right balance, it's always the least non-optimal position at any point in time as things shift around. I don't know if
And when you get stressed, do that.
If
Yeah.
you're going to use AI to tag a huge amount of data, right? You have an algorithm, you run it through. How do you measure the effectiveness of that? Because you don't have people that can go through the millions of records to see how it did.
Right.
Spot-checking or
Yeah, I mean, that's probably, again, a slightly longer conversation, but I think part of it is also how you measure the effectiveness of the AI, of the knowledge management system in general, if people are finding things better, then the tags are probably working. I'm not sure you're ever going to get to 100% accuracy, but if the effectiveness of the use of the content goes up, then you can probably attribute that, if that's the kind of standalone variable. We started auto-tagging things and people could find stuff, or you're trying to drive visualization engines that you couldn't use before, and that increases the effectiveness. That's probably a good thing. On the flip side of that, you're also going to probably find things where people are going to say there was some inaccuracy or some kind of problem may occur because it's just wildly inaccurate, and then you have to monitor those. And again, people are the best at finding those things, and eventually we'll probably have AIs checking AIs, but that's a whole. So thank you very much, and before you run off, can we do a selfie? Thank you.